Well, for those who attend this meeting, it will be great if you can fill out the attendees list under like March 4th. Oh, I find that we got some new folks here. Um, for example, Mathis, do you want, maybe we could do a quick self-introduction for those newcomers. Yeah.
Yes, of course. Can you hear me
Yeah,
first?
yeah, yeah, yeah.
Great. So I'm Mathis Velardos. I work at Mistral, and I'm currently experimenting with disaggregated, just to know how it works. And yeah, that's pretty much it. And I did my first pull request on vLLM, and I think I have two more to push that regarding disaggregated. That's it. And I'm glad to be part of this meeting.
Nice to meet you, Mathis. Yeah. And also, let me see. Bao Long.
Yeah, it's me.
Hey, do you want to do a quick self-introduction?
Okay, this is the first time I joined this meeting. Uh, I I think I'm a newbie f to this area. We Tencent want to start vLLM as a inference engine, and we think IM cache is a good is a better KV cache store. So I want to study it. Yeah.
Nice, nice, nice. Great to see that Tencent is also interested in Ion Cache too. Okay. And
Okay.
yeah,
Yeah, probably some of the folks here know me, but just a quick introduction on my side. I'm from the IBM research, and we are just trying to explore how the vLLM production stack could help.
nice to see you. Great. Yeah, I guess we can get started. The agenda today is like still similar to last time. Like we will go through the discussion items on this Google Doc, and yeah, everyone feel free to bring up your thoughts, your comments to the items that other people are working on. Yeah. So okay. The first item is Chen asking what's your plan to support LoRa adapters KV cache reuse? Yeah, so actually, Chen, do you want to talk more about it?
Yeah, definitely. I actually created two PRs over the weekend last week, and then can anybody share with me the doc link the meeting link, I could put all of those on it. And so one is about like I tried your Helm chart and changing your deployment template a little bit, and then to enable LoRa on vLLM server. And then right now you can actually manually execute doing kube execute into the vLLM pod. Actually dynamically register for example, using Hugging Face libraries to download the adapters you need, and then dynamically register that when vLLM is running. So you can do those manually by hand. So my next step is like in order to automate this process to facilitate users to quickly and easily launch new adapters, right? So I actually make a proposal design in your proposal document, and then proposal document folder. That's the proposal PR, which is still pending reviewing. So what I plan to do is I want to launch a controller for the just managing the LoRa adapter or LLM adapter CRs, and then to dynamically register those LoRa adapters, one adapter or a set of adapters on all the vLLM deployments. So internally, it needs something like some algorithms to determine which which adapter should be registered with which deployment pod, vLLM deployment pod. And then, so the process I explored while the documentation last week can be reused to dynamically add more and then automatically by the controller. So users only need to worry about CR. They don't need to do those manually. And then but I still don't know anything about the router piece and also the KV cache piece. So I don't know how your KV cache can better support different LoRa adapters. So the PR is actually under review right now, and then feel free to leave me more feedback. And then it is just a design for discussion. So if you have any comments, feedback, or any others want to join me to contribute to this piece, it would be fantastic.
Thanks so much, Chen. Yeah, this LoRa adapter thing is really a very useful feature for people to use different customized models in different use cases. Yeah.
Oh, yeah, Chen, actually, I have a very quick question. So I just go through the proposal PR, which is very great. But just a very, very quick question. So to clarify, so if I understand correctly, this proposal is like proposing that each pod could load its own like LoRa adapters, even if those pods are from the same deployment. So I mean, different vLLM instances of the base model from the same deployment, they could also load the different LoRa adapters, right?
So that's probably the more advanced assignment or scheduling algorithm I would add. But for the first PR, what I planned is to load the same base models LoRa adapters on all pods. So that's the default kind of like scheduling or assigning algorithms. And then we can go more advanced, like whether the popular adapters are on the same pod, and then the other set of unpopular adapters are on other pods. So we have some planned algorithm already, and then those algorithms, I will probably pitch that with new proposals later.
Cool. Yeah, great. So I'm asking this because this is probably also related to the router design, since router needs to be aware of those LoRa adapters. So yeah, got it. So thanks for the clarification.
Exactly. So we actually need to maintain a mapping between the adapters registration and the pod. And then this one is really hard to maintain because we can maintain it in the cache of the controller. However, it needs to be shared with the router. So the better place is really to maintain this mapping for each adapter on their CRs.
Yeah.
So, however, on their CRs, there would be a synchronous updating issue because if you have auto scaling, deleting adding a new pod, right? So that cache is actually not aware of this new pod. It needs to wait until the pod creation or deletion event to pass it to the controller to do an update. So there would be some time that you might forward a request to a wrong one. So I also need help to kind of like solve this resilience of fault tolerance issue, right? So if we forward this request to a wrong pod, or the pod has been deleted, what should we do? And I think that's some modification we need to design or update or enhance our router. So it can be another proposal. So right now I'm just proposing the CR and controller.
Cool. Got it.
Mm.
Yeah. So maybe I got some quick ideas. Maybe router could directly monitoring, like looking at the VM paths, monitoring those paths instead of going through the CR. But this could have some extra other different trade-offs. Let's maybe take this offline.
Sure. We can directly leave comments on the PR.
Oh yeah,
My
yeah.
with the
That sounds good.
periodical updating of the VRM status is so you need another control piece on the VRM.
Yeah.
Okay. Yeah, thanks for the great discussion. Does anyone else has any comments or thoughts on this PR on this feature? Okay, if not, like we can go through the next item. I'm not sure if Brian is here or not. But he brings up this like KV cache sharing across multiple nodes. And this one like we have I think Jai this week did some like integration of like P2P transfer across nodes. Do you want to talk a bit more about it, Jai?
Um, yeah. So basically, the our code is already done in the cache, which is like the core of production stack. And for production stack integration, I think it will be soon, probably sometime this week or next week. So the key technique here is that we start normally like start multiple VM engines, and also each VM engines has a local M cache engine, and also there's a centralized lookup server, so that all the cache information is in the centralized lookup server. So each M cache engine could query that centralized lookup server, then it get the address of the and also the port of the cache engine that has the Kiwi cache, so that the connection can be set and then the Kiwi cache can be transferred between them. Yes.
Yeah, so just want to give another potential proposal. So the current way of achieving KV cache sharing across multiple nodes rely on IOM cache. Well, IOM cache only wrap the VM engine. I guess it's maybe still there are some people that are not that willing to use IOM cache. So another potential is to do request duplication. Basically, if the router found that one request prefix is really hot, then they duplicate that request to another engine. This will not increase the TTFT of this request, bring some commutation overhead, but it will allow future requests to be routed to another endpoint.
Okay, that's another design choice, and I think those designs are compatible.
Yeah, they are totally compatible. So just want to bring up a choice where when
Yeah,
the user just
agreed.
does not want to attach any store to the nodes.
Agreed.
Yeah, so Kunai, so this proposal will it be like also implemented maybe in router or something?
It will be in router based on, so basically, uh, it will require like this one will require will require the router to detect what is a hot request. To detect that, it needs to maintain some internal states. So it limits the routing decision to those routers that can calculate and maintain the intermediate, like the internal states of requests. So basically, it needs to be able to estimate the prefix hotness based on some prefix-aware data structure.
but it will be implemented in the router. Yeah.
Okay. Yeah. Does anyone else has comments on this on KV cache sharing?
I guess it actually might be linked with my question a bit below about the support of nickel directly in LM cache. I'll just bump it there because I was wondering why was LM cache was supporting Infinistore by using raw RDMA instead of nickel because there is a topology issue.
Yeah.
Because nickel detect automatically the topology and with different nick. And I was wondering why not implementing nickel connectors directly in LM cache, since it seems that it will be the new way of doing things. At least it seems more mature than the simple connector, I think.
Yeah, I think we're definitely gonna support Nico. Actually, that raw RDMA, which is infinite store integration, is done by a external people that we're actually not that familiar with.
Okay.
So yeah, like both backends will definitely be supported in the future.
Okay. That makes sense.
Hmm.
Okay. Yeah, so Matt is like also asked the question like how will the KV cache be shared on different DP regimes? Yeah. So yeah, Kuntai from the vLLM team and also on cache team, do you have some thoughts on this question?
So currently, there's a Cache PR that is working on exactly disaggregate prefill scenario. Yeah, so basically the key thing for disaggregate prefill is that besides the KV cache, it needs to also store the hidden states. Hidden states is basically the output of prefill. The output of prefill needs to be also stored in order to produce the first token as fast as possible. And I think there's a PR that is adding that functionality, and it should be yeah, but it also requires it requires a change that PR to be merged and the PR author to create another PR to vLLM and that PR to be merged in order for cache to be fully functional for this aggregate prefill without any code change to upstream vLLM. Yeah.
Oh,
Okay.
But
oh,
in short, the answer is yes. We already support different DP regimes, but like, they're not efficient enough. In order for it to be efficient enough, we have to wait for these PRs to be merged.
Okay, so in my understanding, there is two PRs in vLLMs and one in LM cache. Is that correct?
Mhm.
Okay. Could I have the links of those PRs just to look into it? Maybe like on Slack or whatever.
Yeah, sure.
Okay, thank you.
Yeah, send it later.
Great.
Yeah, Maroon.
Yeah, I all one comment on what was just mentioned on supporting the hidden caching or storing the hidden states in LM cache. I mean, that's what you referred to, right? Storing them in LM cache.
Uh, are you talking about nickel or I'm sorry,
No, no, about supporting
DP
sharing
regimes?
KV cache on different DP regimes
Yeah.
and specifically support storing the hidden states. So it's not, I mean, from my understanding, the hidden state support storing the hidden states would enable or is crucial for using the DP architectures, but it's not exactly the same as saving the KV cache. So would that also involve the router, or is it the same? Would it use the same API for KV cache, or should it be something different than KV caching?
It will go through the same set of APIs as the KV cache.
and its invocation, like how would it be invoked in the decode state, the decode instances? So the router would schedule them and have them pull it up, or how would that work exactly?
So basically, the prefeeder, after finish the prefeeding, it will put to ION cache, and then the decoder, while receiving the request, it will try to fetch, it will try to get the KV cache and the hidden states from ION cache, and in that put and in that get, there will be transfer happening.
Mm. I think we can take this offline.
Yeah, thank
Thank
you.
you.
Yeah, actually, I have another quick question, maybe a dumb question, but just want to understand more about this hidden state stuff. So, in my understanding, like if it does not send the hidden states, but just let the decoder to generate the hidden states, it's just like bringing the overhead of decoding one token, right? So why this single token overhead is will like create so much, because in my understanding, like supporting saving hidden states will include a lot of like code complexity, but just like for this improving the latency of the decoding a single token. So just want to understand more about if is am I missing anything important about the potential performance overhead here.
Yeah. So currently our implementation is the same as what you had said. Um, yeah, so Kunta, do you want to chime in a little bit?
On this because you're more familiar with literary previewing vLLM.
Oh, sorry, can I say the question again? Sorry
Oh,
for like
sorry.
being
My
out
question
for a second.
is just want to understand the potential overhead of like generating the hidden states on the decoder instance.
Basically, one intertoken latency.
Yeah, but it's just one intertoken latency, right? For example,
12
if
to
you're like
13 milliseconds.
sorry.
12 to 13 minutes. So basically, for example, for Llama 8B, if you're pre-filling using, for example, like 2000-ish tokens, which is a typical chat scenario,
Uh-huh.
in that case, the prefill time is around 50 to 60 milliseconds IRC. So if you're inflating that by interval latency, it's a little bit large.
Wait, interesting. So you're saying prefilling 2000 tokens takes 50 to 60 milliseconds, but decoding a single token
What?
also requires like 10 to 30 milliseconds.
10, 10 to
That
12,
basically
10
means
to
the
12. Yeah.
prefilling throughput is 1000 times higher than decoding throughput. Or maybe we can take this offline, but I
Let's do
roughly
the measurement
understand
offline. But
if
yeah,
the
my point is that if you like your like the 10 milliseconds ish overhead is most likely inflating the usual chat use case overhead by 10% or yeah, around that. And that part overhead could be easily covered by engineering, but there's a lot of other overhead that cannot be covered by easy engineering. So that overhead seems to be the easiest to reduce overhead compared to doing better async, doing better scheduling, those kind of things.
okay,
Mm.
I see.
And if you squeeze juice from like better async and better scheduling, you won't be able to squeeze out 10 milliseconds.
Okay. Yeah. If there are no comments for this feature, then we can move to the last the next one. Okay. Yeah. So Brian asked like whether like on cache model will support wider range of models in the future. Yeah, Jiayu from the Cache team, do you want?
Yeah, the answer is yes. For a basic Cache version, we're definitely going to support as many models as possible. In fact, I'm working on this DeepSeek support.
Mhm.
And also there are some compression modules in Mcache which requires some kind of more effort to integrate to more models. But yeah, we're trying to support as many models as possible. Yeah.
Great, great, great. Supporting DeepSeek will be a very important feature that many people would like to see, I guess. Yeah. Okay.
Yeah, but by the way, so for the DeepSeek model, since it involves the thinking phase, it slightly complicates the disaggregate preview part. Yeah.
Yeah, sure.
Yeah, that makes sense. Okay, so the next item is Kuntai, do you want to give some quick update on prefix cache aware routing?
So basically the current prefix cache aware routing will give two new abstractions. One is affinity, basically calculating which endpoint has the highest affinity to this request. And given a set of available endpoints. And if multiple endpoints have the same affinity, we'll randomly choose one. And the second part will be load filter, basically filtering out the endpoints based on the load. So this load filter will be just one example filter. There will be also other filters we plan to release in the future. And it is currently pending on the router refactor PR, and I'm planning to raise the PR, like give the PR out, let the PR out after the router refactor PR is merged.
Okay.
Oh, quick
Yeah.
question. Quick question. Not quick. Sorry, I got a lot of questions, but just wondering whether this the affinity and load filter, those lo intelligent logic could be customized by us. So will there be an interface for different people to
Yes.
customize?
Yes.
Okay, cool. Nice to know that.
Cool. Yeah, so and
Yeah.
uh
I guess we already discussed this error preview and we can skip this one. Yeah.
yeah. And Kuntai, do you want to give a plan for
Like I'm mentioning this to like basically to ask what's our plan for V1. So as a background to other guys, vLLM V1 is basically a major refactor to vLLM engine, and it basically has much better performance than the original engine, but it also complicates the cache integration part, and it also disables some features. So since it is and that seems to be a major bet from the VM team to move, like they are pretty determined to move everything to V1. So I guess we need to be prepared early. And here's the V1 doc. It basically introduces what's the new V1 features, what's the features that V1 supports, what's the features that V1 doesn't support currently. Yeah.
Yeah, so actually like for production stack, we right now enables the V1 environment variable to turn V1 on, but I'm still working on like implementing the Ion Cache connector in its V1 version. Yeah, so hopefully this PR should be able to submit within this week. Yeah, and I can give a quick update on this part like next in our next community meeting. Yeah. Okay.
Cool.
So, yeah, we have one last item. Maybe we can talk quickly go through it. James.
Yeah, I just wanted to share that I am probably 90% done with that Terraform tutorial that I said I was going to do. I am definitely not going to have a blog done for that by the 6th, which was what I was originally aiming for. And there's just a couple small issues I'm still trying to fix on the tutorial. But I'm hoping the tutorial should be done this week. And then maybe the following week, I can get a blog post up so that you all can send that out and still have that content for that.
Nice, nice, nice. Thanks a lot, James. This is really helpful. Yeah.
Yep, happy to do it.
Cool, cool, cool. Nice. Yeah, I think that's almost that's mainly it for this community meeting. So yeah, our next one will still be 4 p.m. A PT on next Tuesday. So yeah, if you guys are able to join, feel free to join that one too. And I will send reminders before the community meetings too. Okay, yeah, nice to see everyone here, and we hope to see you all in the next meeting. Okay, bye.
Okay, thank
Thanks,
you.
everyone.
See you.
Bye.
Thank you.
Have a good one.